Hello class, in this lesson in 3.8 you're going to learn how to use the quadratic formula to find the zeros of a polynomial function and find the zeros of a polynomial function. So let's start by first going over radicals. Alright, so we're going to be working on today is radicals and knowing how to simplify radicals. So there's going to be a review from algebra 1 and algebra 2. Now radical expression again is anything that is in this format right here, where this number on the outside, your index, like 2, 3, 2, 3 or 4, okay, identifies the number of factors the radicand, which is this number inside the square root, inside the radical, is going to be broken up to. So right here we'll find 2 identical factors of the radicand, we'll find 3 identical factors of this radicand, and 4 identical factors of this radicand. Now today we're going to be looking at indexes of 2, so square roots, radicals with an index of 2, so square roots of radicands. And there's 2 cases that radicand can fall into. It could fall into that the radicand is a perfect square. So when we take the square root of our perfect square, we're going to end up with a whole number, a rational value. Or it could be that our radicand is a non-perfect square. And to simplify those situations, we have to simply factor the radicand using the largest perfect square and then take the square root of that perfect square and leave the other factor inside the radical, under the radical. So let's first find a list and let's create a list of perfect squares. Our perfect squares starting off with 1 are 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10, just to start off with the first 10. So when our radicand is not one of these numbers here, we want to simplify this by factoring out the largest perfect square, the largest number from this list. So let's look at an example of this. Let's look at example the square root of 44. So the square root of 44. So from our list of 1, 4, 9, and so on, we want to find the biggest number that is a factor of 44, which means that divides 44 without a remainder. And that biggest number is going to be 4. So I can break down the square root of 44 as the product of 4 times 11. So basically the square root of 44 times the square root of 11 is equal to 44. And again, since the square root of 4 is a perfect square, taking the square root of 4 is going to give us 2. So we can simplify 44 as the product of 2 times the square root of 11. So this is how we simplify this. And again, this is just exactly how we do any one of these examples. So let's say 120. 120, the square root of 120, again, from our list of perfect squares and so on, 120 can be written as the product of the square root of 4 times the square root of 30. 4 happens again to be the largest perfect square from this list. Of course, 1 is always a factor, but we want to look for some things greater than 1 from this list. And it also happens that 4 happens to be the largest and only perfect square factor of 120. So taking the square root of 4 again gives us 2. Multiplying it with the square root of 20 gives us, 30. It's going to stay as the square root of 30. So our simplified form is 2 times the square root of 30. Let's do a couple more examples. So here, 4 happens to be again 60. The square root of 60 can be broken up as the product of the square root of 4 again times the square root of 15. So our simplified form is this. And for 24, same thing. It just so happens again by pure coincidence I decided to pick numbers where 4 was the square root. So 24, that 4 happens to be the factor, the only factor for all of these. But again, it's just pure coincidence. I should have done a better job in preparing and again finding different numbers. But again, the idea is simply that. So we end up simplifying this to 2 times the square root of 6. And again, it works with any number that has a perfect square factor. So for example, like 18. 18 from our list of perfect squares and so on, 18 can be written as the product of 9 and 2. So the square root of 9 times the square root of 2. And since 9 is a perfect square, that would be 3 times the square root of 2. So this would be the simplified form for the square root of 18, while this is a simplified form for the square root of 24. Okay. Now, not every number has a perfect square as a factor. For example, the square root of 21. This does not have a perfect square factor. The factors of 21 are 1, 3, 7, and 21. And you notice again that from this list, none of these numbers are perfect squares. So you're not going to find a perfect square factor in some of these numbers. So like in this example, you won't be able to simplify this number any further. Now, the reason that this is going to be important, this skill is going to be important, is because we're going to be using the quadratic formula in today's lesson. Now, the quadratic formula is used to solve any quadratic equation in the form of ax to the second power plus bx plus c equal to 0. In other words, anytime I'm looking for the 0 for a quadratic equation, this right here, finding the 0 for a quadratic equation, I can use the quadratic formula here by using the values of a, b, and c and plugging them in to these respective places. So let's look at an example of this situation here. So let's say we have the quadratic function f of x is equal to x squared minus 4x minus 13, and I want to find the 0 to this quadratic equation. In other words, I want to figure out what's going to make this equal to 0. Now, normally we can rely on our factoring skills to find the factors, the two linear factors that multiply to give me this quadratic. But unfortunately for this example, because I want factors of negative 13, which is a prime number, 1 and 13 are the only possible options. So it could be positive 1 or positive 13, negative 13 or negative 1, but either of the two situations does not work because they are not going to add up to this middle number of negative 4 like they should. Factoring or multiplying this out is going to equal to x squared minus 12x plus 13, minus 13, or x squared plus 12x minus 13. Notice again that that middle number is not going to be negative 4. And the reason for that is because this is not factorable. So we cannot use this technique of factoring in order to find the linear factors and then figure out what makes those equal to 0. So we have to use a different technique here. And this technique is going to be the quadratic formula. This quadratic formula here works for any quadratic, and it can help you solve any quadratic, even again those that are factorable. So this works every single time. So if you ever get stuck, just rely on this formula here and you can figure out the zeros to any quadratic equation. So let's see how we use that value there. First, we have to identify the values of a, b, and c, and they're basically just going to be the coefficients of each term. So for the quadratic term, the coefficient is 1, so that's your a. For the linear term, your coefficient is negative 4, and for your constant term c, that value is negative 13. So plugging it into this formula here, we're gonna again get our solution. Let me just do something real quick. Let's copy that. All right, so for B, negative b, this part here, that is the equivalency of saying negative 1 times the value of b. Negative b means negative 1 times b. So negative 1 times the b value of negative 4 plus or minus the square root of b, which is negative 4 to the second power, minus 4 times a times c. So I'm just simply plugging in the corresponding numbers to those variables. That's going to be divided by 2 times the value of a. And we can now simplify. So negative 1 times negative 4, this part here, that's going to equal to 4 plus or minus. And I'm going to take it step by step. If you have, again, with your decimals calculator or your 84, you can write all of this in one single step, not the square root part, just the numbers of negative 4 to the second power minus 4 times 1 minus 13, and just get the answer immediately. But I'm going to take it step by step. So I'm going to start by first raising negative 4 to the second power. That should always be a positive number. Make sure that if you're using a calculator that you put the -4 in parentheses, so -4 to the second power, that's going to equal to positive 16 again. And like I said, this number should always be positive. Now multiplying -4 with with 1, so multiplying -4 with 1 and -13, that's going to equal to 52, positive 52. So we're going to put plus 52. And well, 2 times 1 here in the denominator, that's equal to 2. And let's add 16 and 52. That's going to equal to a total of 68. And divided by 2. So this is our 0. This is what x is going to equal to. All we have to do now is just simplify. Let's simplify some things, and we get our answer. We'll start by first simplifying the square root. All right, notice I can divide 4 by 2, but I want to first simplify the square root of 68 by seeing again from my list of perfect squares, my perfect squares again are 1, 4, 9, 16, and so on, and see if the biggest number again from this list. I can create a list of factors for 64 and see if any of those numbers are in this list here, or I could just simply start dividing 68 by 16, by 36, and so on. And the biggest number actually happens to be 4. 68 divided by 4, that's going to give us a total of, that's going to give us a quotient of 17. So if I multiply 4 with 17, that gives me 68. So the square root of 4 is equal to 2. So I can rewrite this as the product of that. So x is going to equal to 4 plus or minus 2 times the square root of 17, and then divide that by 2. So now you can clearly see that these three numbers can all be divided by 2. They have a common factor of 2. So if I divide 4 by 2, that's going to equal to 2. And if I divide the 2 by 2, that's going to equal to 1. So 1 times the square root of 17, which can be just written like this. So here are the two solutions. These are the zeros for x. X is going to equal to 2 plus the square root of 17, and x is going to equal to 2 minus the square root of 17. Those are the two zeros for this quadratic. Let's see, let's do another example. So again, we want to find the zeros to this function. So we want to identify what's going to make this thing equal to 0. And again, factoring is not going to be an option here. So I'm not even going to bother trying it. I'm just going to go straight into identifying the a, b, and c values so I can plug them into my quadratic equation. So here we're going to plug in okay. Why isn't that pasting? I wanted to paste something, but never mind. Nope, not working. All right, so let me just write it. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So negative b again, starting with this. Negative b means negative 1 times the value of b plus or minus the square root of 6 squared minus 4 times 4 times negative 12 divided by 2 times the value of a. So continuing over here, we're going to get negative 6 plus or minus the square root 228. I just did it all in one single step this time. So I just simply did all that one single step. We end up with that, and we end up with 8. So again, I want to simplify 228. And luck would have it that the greatest perfect square, that this can be broken up by using the perfect square of 4 and 57. 4 happens to be the only perfect square factor of 228. So we can write this as 2 times the square root of 57. So x is equal to negative 6 plus or minus 2 times the square root of 57. And now this time, 8 doesn't divide 6 and 2, but they do have a common factor, so I can write this as negative 3 plus and minus 1. I can divide everything by 2 by the common factor of 2, and I end up with this. So here are my zeros. My zeros are going to be that x is going to equal to negative 3 plus the square root of 57 divided by 4, and negative 3 minus the square root of 57 divided by 4. So those are my two zeros. Now, we use this scale again now to simplify polynomials of higher degree. Let's say we have a polynomial of degree 3. Well, using our rational zero test, I can find the possible rational zeros by getting the factors of my constant and dividing them by the factors of my leading coefficient, which in this case is going to be 1. So the factors of 5 are simply going to be these four numbers here: 1, positive 1, negative 1, positive 1, positive and negative 5. So using a rational zero test, we can test out these four numbers and see if any one of these four numbers is going to be a rational zero. So let's start with positive 1. Let's see if positive 1 is a 0. So this is going to be negative 1. No, that's not going to work. Let's do negative 1. So this is going to equal to negative 1, which equals negative 3. Negative 3 times negative 1, that's positive 3. This adds up to negative 5. And negative 5 times negative 1 is positive 5 and equals to 0. So this is going to be a 0. So x is going to equal to this 0 right here of negative 1. And as a result, we have now a factor that is a quadratic factor. So we have 1x to the second power minus 3x minus 5. And to figure out what makes this equal to 0, normally, again, we would use factorization. But because this is not factorable, we're going to rely on our quadratic formula, where a is going to be 1. It's just already in order for me. A is 1, b is negative 3, and c is going to be negative 5. So we're simply going to plug that into, again, this formula right here. So x is going to equal to negative 1 times the b value plus or minus our b value, which is negative 3 to the second power minus 4 times the value of a, which is 1 times the value of c, negative 5, all divided by 2 times the value of a. So x is going to equal to 3 plus or minus, and let's plug all of this into the calculator. Let's plug all of this into the calculator, and we're going to end up with a total of 29 divided by 2. Now 29, the factors of 29 are just 1 and 29 because it's a prime number. So 29 does not have a perfect square as a factor. So we cannot simplify this any further. So here are our answers there. Therefore, since there's no simplifying to do, we have our possible zeros. X is going to equal to 3 plus the square root of 29 divided by 2. 3 minus the square root of 29 divided by 2. And of course, the one rational zero that we got by testing again the values from here, which is negative 1. So these are going to be the 3, again we're supposed to have 3, the 3 rational zeros. So there you go. So the idea again is to test again one of the values and then find the other rational zeros by again the two irrational zeros by using the quadratic formula. Now, if our leading coefficient is not 1, let's say in the next example, leading coefficient is not 1, so normally we would find the list of possible rational zeros by getting all of the factors of 9, which are going to be 1, 3, and 9, and dividing them of this number right there, all the factors of 9, and dividing them all by the factors of 2, which are 1 and 2. This is how we're going to get our list. I'm going to start by first dividing all of these numbers by 1 so I can get just whole numbers. So that's going to start off by 1, 3, and 9. Of course, I would then divide all of these numbers by 2 and I would continue my list. But since these are whole numbers, I'm going to test these numbers first, and if none of them work, then I exhaust these possible solutions, then I will then divide these by 2 and then try those numbers. But I'm going to start off by just looking at the whole numbers and testing the whole numbers. So we have, let's test positive 1. Just go in order and test positive 1. So we have 2, 4, negative 9, and negative 9. So this is 2. This is going to be 6. This is also going to be 6, negative 3. So no, this is not going to work. So negative 1 is not going to work. So let's test something else. Let's test we tried 1. Let's test negative 1. So this is negative 2. No, this is not going to work either because it's going to be now positive 2. No, this is not going to work either. So let's test 3 then. You know what? Let's test negative 3. So this is negative 6, which is going to give us negative 2. This multiplies to positive 6, gives us negative 3, and multiplies to positive 9, which gives us 0. So there, negative 3 worked. So now as a result, we have this quadratic of 2x squared minus 2x minus 3, and we want to figure out what makes this equal to 0. But again, since this is not going to be factorable, because that's what the whole idea of today's lesson is that this quadratic term is not factorable, we're going to just simply jump into the quadratic equation. So we're going to plug in our values into this formula here. So x is going to equal to negative of negative 2, which is positive 2, plus or minus. I'm kind of skipping some steps here and doing two things at once. So the negative of negative 2 is going to be positive 2. B to the second power, which means negative 2 to the second power. That's going to be 4. And then multiplying a negative 4 times a positive 2 and a negative 3, multiplying those three things together, that's going to equal to positive 24. Yeah, positive 24. And then 2 times 2, that's going to equal to 4. 2 times our a value is going to be 4. So we're going to end up with 2 plus or minus 28 divided by 4. And the square root of 28 can be broken down by using the factor of 4 and the factor of 7. So we can simplify this to 2 times the square root of 7. So x is equal to 2 plus or minus 2 square root of 7 divided by 4, which simplifies because these three numbers all have a common factor of 2, which simplifies to 1 plus or minus 1 times the square root of 7 divided by 2. So here are our zeros. X is going to equal to 1 plus the square root of 7 divided by 2, 1 minus the square root of 7 divided by 2, and the other one is going to be, again, this rational zero, which is negative 3. So here are our 3 zeros. Let's do a couple more examples. This is the last 2 examples. So here again, we want to figure out the list of possible rational zeros by getting the factors of our 14. And the factors of 14 are 1, 2, 7, and of course 14. And we want to divide those. We want to divide those by the factors of 7. Which the factors of 7 is 1 and 7, since 7 is prime. Well, dividing the blue numbers, these numbers by 1, is going to give us, again, just simply 1, 2, 7, and 14. This is a 7. Let me write that better. There you go, 7. So, dividing those, again, we're going to end up with the following. And again, we would then divide them by 7, but I want to just work with these because those are the whole numbers. And if we exhaust those, then we'll look at the rest of the list. So let's see what we can use. Let's start with, let's see, positive 2. Let's see if positive 2, we get lucky with that. Probably not. Let's see, 7, negative 13, negative 9, and 14. Let's see, this is 7. That's 14. That's going to be 1. This is going to be 2, negative 7, and yep, negative 14, so that one works. So positive 2 is one of those. And again, because this is not going to be factorable, automatically just going to use this as a, b, and c and plug it into, again, my quadratic formula. So x is going to equal to negative 1 plus or minus 1 to the second power minus 4 times negative 4 times 7 times negative 7. That's going to equal to a total of 196, and divide that by 14. Oh, positive. It should be positive. So adding the 1 with 196, that's going to equal to 197. I meant to say 196 right here earlier. I kind of automatically added it with 1, but that's going to give us 197 divided by 14. Now 197, the factors of 197 do not have a perfect square as a factor. 4, 9, 16, and so on. Those are not factors of 197, so I cannot simplify this any further, which means I have my answer already. So x is going to equal to negative 1 plus the square root of 197 divided by 14, negative 1 minus the square root of 197 divided by 14, and of course the rational zero of 2. So these are the three zeros for this polynomial. And that leaves us just with one more example. This last example here, same situation. We'll start by finding the factors of 2, which are simply just 1 and 2, divided by the factors of 4, which are 1, 2, and 4. And dividing them by 1 first gives me these factors there. So let's exhaust these factors here and these possibilities first before we divide 2 by 1, 2, and 4. That way, if I get lucky and my answer is among one of these 4 numbers, I don't have to look at the rest of the list. So let's see, let's try positive 1. So this is 4, that will give me negative 4. I'm sorry, positive 4, which adds up to negative 4. Negative 4, which adds up to negative 2. Negative 2 and 0. So positive 1 worked. So with this a, b, and c, I can jump straight into my quadratic formula and plug them into the corresponding places. So we have negative of negative 4, that's positive 4, plus or minus 4 to the second power, which is 16, and multiplying again these values, negative 4 with positive 4 and negative 2, that's going to equal to positive 32. Divide that by 8. 2 times 4 is 8. And we can add 16 with 32, which is a total of 48. Of course, inside the square root. So this is factorable. And 4 is a factor, but so is 16. 48 can be divided by 16. So this 48 has 2 factors that are perfect squares, 4 and 16. So we're going to use the 16 since the 16 is larger. The key idea is to leave whatever's inside the radical as smallest as possible. And if we use 4, this number would be bigger still. So we're going to use 16, so this number is smaller, and the square root of 14 is 4. So we can rewrite this as 4 plus or minus 4 radical 3 divided by 8. And then reducing all of these by a factor of 4, we get 1 plus or minus 1 times the square root of 3 divided by 8. And those are going to be my 2 irrational zeros. So x is going to equal to 1 plus the square root of 3 divided by 8. And instead of writing the second time, we're just going to put the minus sign right there. And 1 minus the square root of 3 divided by 8. But those are the 2 irrational zeros. And of course, my third and final zero is this one rational zero of 1. X is going to equal to positive 1. So here, again, are the 3 answers. And this is another option of how to list your answers. Instead of separating like I did in the previous examples, I can just write it as one term, as one expression. But again, it has the 2 answers there. The adding of 1 and the square root of 3 and the subtraction of 1 and the square root of 3. Well, there you go. Again, thank you again for watching. If you do have any questions, do not hesitate to ask. Again, send me a message on reminder email. And I hope you all have a great day.